Okay, in this video we're going to have a quick look at how a DC motor works. So first off we need to know what the parts of the motor are. So we've got a few bits in here that we need to know. So first off we have a permanent magnet up at the top here. We've also got a coil of wire that is in the middle here, and we've got this thing in the middle here, this thing at the side, which is called a split ring commutator. Two M's. So what happens with this is, first off, current is going to flow through the wire here. So when you switch on this switch and connect that up, then current is going to flow through the wire, wrong way, and into our coil. Okay, so we've got the current going through our coil like so, and back to the other side of the cell. So we can see which way the current is flowing, and we can see it flows in this way and back out this way. Now that's important because with the current flowing differently on both sides, that's going to have an effect on how the wire is going to move on each side. Okay, so I'll get rid of these bits here just so I can get a bit more space to write about what's going to happen with this. But first things we need to know are, what sort of magnetic fields do we have around at the moment? So we know that in between the North and the South Pole we have a magnetic field going across like this. Okay, so that would be my first key point when I'm answering a question on this. So we've got a permanent magnetic field . Okay, and we know that that is going north to south. We also know that we have got a electromagnetic field that goes around the wire, and we also know that the current is going from positive to negative, and we've drawn that on there. And we know that these two fields will interact with each other. So that's the kind of basics. That's why the wire is going to move in the first place. Then the more important bit about the actual motor is, which way is the wire going to move on each side? Okay, so if we take a look at each side, so we'll do, so first off we'll focus on, if I do this with my magic pen, this side here. Okay, so if we're just focusing on this side here, we've got our field going across this way from north to south, and we've got our current, it's not going that way, it's going that way, so it's kind of like this, and you can see my thumb is going down. So the movement there is going to be going down. Okay, so this side of the wire is going to move down. And if we again go to focus on the other side now, okay, this time we've still got our field going across like that. This time my current's coming out this way. Okay, so that means that this side is going to move up. Right, so this side is going to move up. So what I would say in my answer for this is I'd split this up, okay, into like the left and right hand side of the wire. So the left hand side of the coil being the one closest to the north. So I'd say left is going to move up, and if in my answer I would just say due to Fleming's left hand rule. Okay, I wouldn't like go into too much detail explaining why that is. I'd just say that it does, and I'd say the right is going to move down. again due to Fleming's left-hand rule. And that is going to cause the wire to spin, or the coil to spin, and that's what spins the motor. Okay, now if we think about what's going to happen as well, once the coil is spun by 90 degrees from where it is now, or once it's spun a complete 180 degrees at least, it's going to switch from one side of the split ring commutator to the other. So you'd explain that the current will switch every half turn. Okay, so the current's going to switch every half turn. In fact, I'm just going to pop this bit to the side. Can I? So the current's going to switch every half turn, and you kind of go on to explain that that's going to mean that the force is always pushing the same way. Okay, so you're always going to be getting, because that's pushing that way, it's always going to be turning in this direction. And when it's switched to 180 degrees, the current will switch, so the same side will be pushing down and up. Okay, so that's what you then need to kind of get into your full answer. Okay, so explaining what is going on with the permanent and electromagnetic fields and how they interact, and then go on to talk about how each side is going to move. Okay, so how is the left hand side going to move and how is the right hand side going to move, and then talk about at the end how are they going to switch and keep moving in the same direction.